Alright, this is your test 2 review. The first problem is use transformations to graph the function y equals 2 sine of x. So if we know what y equals sine of x looks like, which a rough sketch is right here. Now you start at the origin, then you go up, have a high point, cross, decrease, cross, have a low point, and then come back up. And that would be one complete period. So if we're looking at these multiple choices here, the 2 in the front, that adjusts the amplitude. That doesn't move the graph up or down, left or right. That just changes the high point and low point. Alright, so if we look here, you can see that B would be your answer because you see cross at 0, 0, your high point's 2, your low point's negative 2, and one complete period would be starting at 0, ending at 2 pi. Alright, so that one would have to be B. Alright, number 2, y equals sine of x plus 4. So if we know what the sine of x curve looks like, the plus 4 right here, that's going to shift the graph 4 units up. Okay, so this first graph is shifted 4 units up. It does cross at that, and then we go up, have a high point, down. This is where your function would usually cross the x-axis at pi. Down, down, have a low point, and then start back up, and it would touch the axis again at 2 pi. So it's got to be A. That's a sine graph that's shifted up 4 units. You see, it wouldn't be B because B just adjusts the amplitude. It wouldn't be C because it shifted up 5 units and it's a cosine graph. And it wouldn't be D because it shifted down 4 units. It is a sine graph, but it shifted down 4. Alright, number 3, y equals 2 cosine x. The only thing that's going to change is the amplitude. Alright, so if we know what the basic cosine graph looks like, start at a high point, go down and cross, have a low point, come back up and cross, and end at a high point. That's one complete period. So this first graph here, it's not A because that would be 2 sine of x. That's the sine graph. It's not B because it's shifted up 2 units and because it's the sine graph also. We're looking for the cosine graph with an amplitude of 2. It couldn't be C because this graph is shifted up. You see, it's shifted up. It looks like it's the cosine graph just shifted up 3 units. Or maybe, yeah. D is the cosine graph. Notice the high point of 2, the low point of negative 2, and one complete period is 2 pi units long. So it's got to be D. Number 3 has to be D. Alright, y equals cosine of x minus 3. So we need to know what the cosine of graph is going to look like. And then minus 3, that's going to shift the graph down 3 units. So that doesn't change the amplitude. The amplitude is still 1. It's just everything is going to be shifted down 3 units. Alright, this first graph is the cosine graph, but it looks like it's shifted up. Alright. This second graph it is shifted down 3 units, but that's not the cosine graph, that's the sine graph, because it's crossing here on the y-axis. So that's x equals 0, it's crossing. That makes the sine graph. Alright, C, this looks like the amplitude has been adjusted 4 units. And it's also negative because we're starting at a low point here. This would be y equals negative 4 cosine of x. Well, we want y equals cosine of x minus 4. Is it minus 4? No, minus 3. Alright, look at this graph. High point of negative 2. So usually we have a high point of 1. If it was shifted down 3 units, that would be a high point of negative 2. It's the cosine graph too because it's starting at a high point. And it goes down, up, one complete period ends at 2 pi. Okay, so that means number 4 has to be D. Alright, so now let's look at some of these. Without graphing the function, determine its amplitude or period as requested. Alright, find the amplitude for number 5. Remember, the amplitude is the absolute value Remember, the amplitude is the absolute value of the number in front. Alright, so that's going to be absolute value of negative 5 or 5. Okay? So that one has to be D. Number 6, find the amplitude. The same. Amplitude is going to be equal to the absolute value of the number in front. Absolute value of negative 2 is 2. Alright, so the amplitude for number 6 is B, as in beta. Number 7, the amplitude. Absolute value of 2 again. The absolute value of the number in front. So that's 2. Which is D. Number 8, find the period. So we have y equals cosine of 5x. The period for sine, cosine, secant, and cosecant is 2 pi divided by omega, or 2 pi divided by, omega is what's in front of the x, so 2 pi divided by 5. So it's 2 pi over 5, or 2/5 pi. And that's D. Number 9, find the period of y equals 3 cosine 1/4 x. So the period for sine, cosine, secant, and cosecant is 2 pi divided by omega. So it's going to be 2 pi divided by whatever's in front of the x. So 2 pi divided by 1/4. Flip and multiply, so you're multiplying by 4 over 1. 2 pi times 4, that's 8 pi. So your period for that function is 8 pi, C. Alright, the next problem, number 10, find the period. Y equals 3 cosine of x. Notice there's nothing in front of the x, so that's understood to be a 1. So the period is going to be 2 pi divided by omega, or 2 pi divided by 1, which is 2 pi. So the period of number 10 is 2 pi c. Alright, on these we want to find the phase shift of the function. Now remember to find the phase shift if we have something in parentheses with our x, that means we're going to have a phase shift. Like if we have plus something or minus something, it has to be in parentheses though. Alright. Don't get that confused where if we just had like plus 5 out at the end, that wouldn't be the same thing. And so the first thing we need to do when we notice there is a phase shift is if there is an omega, if there's something in front of the x, then you want to factor that something out. Now on this problem it's just a 1x, so you don't have to factor anything out. So to figure out the phase shift formula has a minus in it. So since the phase shift formula has a minus, that means that if we have a minus here, then whatever number we have here at the end here, that's going to be our phase shift, and since there's a minus in front, it'll be a positive phase shift. If it was a plus in front, it would be a negative phase shift. So our phase shift here is pi over 2. Now remember, that's also considered to be your starting point if you were graphing. Now positive pi over 2, if you're talking about on the x-axis, that's because that's what that means. That's what we're starting on the x. Usually we start at 0, but a phase shift of positive pi over 2 means that we're going to start pi over 2 units to the right of 0. So if we look at our choices here, pi over 2 units to the right, that's the phase shift. Okay. Now let's look at number 12. The same directions, find the phase shift. You can see there's an omega there. There's a number in front of the x. So that's going to change things up just a little bit, because we have to factor that omega out to begin with. So we'll have y equals 4 sine of, now we need to factor this 4 that's in front of the x out. That's going to leave me with x minus, now you may be saying, well, this last term doesn't have a 4. How can I factor a 4 out? The way that you factor the 4 out is by dividing this last term by 4. So you have pi over 2 divided by 4. Flip and multiply. So you have pi over 2 times 1/4. That gives you pi over 8. So now we've rewritten the function so that I can figure out the phase shift. Alright, the phase shift is going to be a positive pi over 8. So that means that we will shift the graph pi over 8 units to the right. So the answer on number 12, what's the phase shift? It's going to be pi over 8 units to the right. Alright, on number 13, graph y equals negative cotangent of x. We need to know what the graph y equals cotangent of x would look like. So recall that cotangent is going to be undefined at 0. So you have a vertical asymptote at 0. Also recall that the period for tangent and cotangent is pi divided by omega. So that means it's pi divided by, on this problem, pi divided by 1. So it means the graph is going to repeat every pi. We can use that fact if we know that we're going to have a vertical asymptote at 0 and the period is 1 pi, then we're going to have a vertical asymptote again at 1 pi. You say 0 plus 1 pi. Then you're going to have another vertical asymptote if you add pi to that again at 2 pi. You're going to have another vertical asymptote if you add pi to that again at 3 pi. Okay, and so you know those are places where we will have vertical asymptotes. Just by remembering that we have one at 0 here. That means we could write like a dotted line. That's our vertical asymptote. We'll have another at pi. We're using the period to get that. Another at 2 pi. Another at 3 pi, so on and so forth. Okay. You can also speed things up a little bit graphing this. Once you have the places where you have vertical asymptotes, then the points that are exactly between any two vertical asymptotes, the point that's exactly between those 2 points, will be a place where your graph crosses. So the point between 0 and pi, you say 0 plus pi divided by 2, that's pi over 2. So we know that we will cross there. Now once you know one place, you can either use the period to get other places, or you can just add any 2 places where you have vertical asymptotes and divide by 2, and you'll get another place. Any 2 consecutive places we have vertical asymptotes. Okay. Now, also remember, if it was just the cotangent graph, it'd be up and to the left and down and to the right, but we have a negative in front on number 13. This is y equals a negative cotangent. So instead of up and to the left and down and to the right, you have to flip the graph. So that makes all of your graphs go up and to the right and down and to the left, just like the tangent graph would. So that's what we're looking for there. We want to compare our graph to the ones we have down here. The first graph crosses at 0, so we know that's wrong. The second graph, we do have a vertical asymptote at 0. We cross at pi over 2. Looks like we have a vertical asymptote at pi. You say, how do you know there's not a dotted line there? But the way that I know is because I could draw a dotted line there. Okay, it looks like it's going to be B. That's the only one that's up and to the left and down and to the right that crosses at pi over 2, 3 pi over 2, 5 pi over 2, or has vertical asymptotes at 0, pi, 2 pi, 3 pi, so on and so forth. Okay, so the answer there is B. Alright, nope. It is negative. How did I draw my graph? I drew it right and picked the wrong one. Nice. Alright, so I did all the work for nothing. Let's look back down. It's not going to be A or B because it doesn't look like our graph. Guess I should have pulled my graph and kept it there. Alright, so if we compare our graph to A and B, it looks nothing like that. Compare our graph to C. Close, but it looks like this is crossing at 0. Okay. Compare our graph to D, and that's our graph. Okay. You can see we have a vertical asymptote at 0. We cross at pi over 2. We cross at 3 pi over 2, We cross at 5 pi over 2, so on and so forth. Use your graphs if you do make them out. Alright, now let's look at y equals now let's look at y equals 3 tangent 2x. Now, the 2x part, that's going to change the period. The period for tangent and cotangent is pi divided by omega. So pi divided by 2. That means the graph is going to repeat every pi over 2. So if we can figure out one place this graph crosses, we can use the period to find other places where the graph crosses. Alright, we need to remember that at 0, tangent is equal to 0. So I plug in a 0, taking the tangent of 0 times, I have a 3 in the front, but the tangent of 0 is 0 times 3 is still 0. Since the period is pi over 2, that means that if I add pi over 2 to that, I'm going to get another place where the graph will cross. Add pi over 2 again, another place, another place. Or you could subtract pi over 2 over and over and over. Okay? So we're going to cross at all of those places. Now, directly in between any two places where this graph is going to cross, there's going to be what? Vertical asymptotes. So, even if you don't label it, you could still draw a vertical asymptote. Okay? So, once you have a couple vertical asymptotes drawn, now the period is pi over 2, the amplitude is 3. The amplitude just makes the graph increase faster, so it won't have as much bow in the graph. Alright, and tangent is up and to the right, down and to the left. Alright, so let's compare this graph that we just come up with our choices. Alright, A. It looks like A crosses at 0, then it also crosses between 0 and pi over 2. That's probably pi over 4. Okay, so it crosses at 0, pi over 4. Now I think that may be like 3 pi over 4, so that's not our graph. Okay, B crosses at 0 and then doesn't cross again until 3 pi, so that's definitely not our graph. C crosses at 0 and then crosses at 2 pi, so that's not our graph. Don't get worried though. Let's look here at D. D crosses at 0, crosses at pi over 2, crosses at pi, 3 pi over 2, just like our graph. Okay, so the answer has to be D. Okay. Alright, number 15, we want to graph y equals secant of x minus pi over 3. Alright, so notice that you're graphing secant. To graph secant, we need to first write down the cosine and graph that. So we want to graph first y equals cosine of x minus pi over 3. Now there's no omega in front of the x. There's no number in front of the x. So I want to now figure out the phase shift. Remember, the phase shift is my starting point. So my starting point is going to be what? Positive pi over 3. That's my starting point of my graph. My ending point is going to be my phase shift plus my period. So my phase shift is pi over 3 plus, since there was not a number in front of the x, we just think about it like it was 1x. So my period is 2 pi divided by omega, or 2 pi divided by 1, which is 2 pi. So my period was 2 pi. So that means my ending point is going to be my starting point plus 2 pi. The starting point was pi over 3 plus the period. Get a common denominator. That's going to be pi over 3 plus 6 pi over 3. So that's going to be 7 pi over 3. So my graph will end at 7 pi over 3. My amplitude is going to be what? 1, because there's no number written in front of cosine, so you just think about the amplitude like the absolute value of 1, which is 1. Alright, so that means I can draw one complete period of this graph between pi over 3 and 7 pi over 3. So now I want to come up with my 4 subintervals so that I can figure out my significant points to help me graph this. So my starting point was pi over 3 and my ending point is 7 pi over 3. Now the way that I get the value that I want to add to each significant point is I take the period and I divide it by 4. So the period was 2 pi. 2 pi divided by 4 is pi over 2. So I want to add pi over 2 over and over and over until I can get to the ending point. Alright, so pi over 3 plus pi over 2, let's think about that like 1/3 plus 1/2. Okay, so that's going to be 2 pi over 6 plus 3 pi over 6, or 5 pi over 6. Alright, add pi over 2 to that, so I'm adding 3 pi over 6 again. Then that would be 8 pi over 6, or 4 pi over 3. Add 1/2 pi over 2, or we said 3 pi over 6 to that again. Well, that was 8 pi over 6. So 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. Now here's where we can tell, did we do this right? Alright, so for this last point here, I can say, alright, 11 pi over 6 plus pi over 2, or 3 pi over 6, better give me 7 pi over 3. Let's see, 14 pi over 6, reduce that, that's 7 pi over 3. Alright, so it does work out right. Alright, so from this I get my significant values. Okay. Now note when I look up here, the graph that's provided I see goes out to, this is 2 pi. That would make the next point here, this would be 5 pi over 2. And then the next point, if we extended it a little bit, would be 3 pi. Alright, so we've got to be careful when we put these fractions in. We need to know where they go. Alright, so we're starting at pi over 3. Well, if this is pi right here, then this is pi over 2. Pi over 3 is just a little bit less than that. So that's where we're going to start our graph. 5 pi over 6 is almost all the way to pi, but not quite. So about right here, that's going to be 5 pi over 6. 4 pi over 3, that's just a little bit more than pi. So it's probably about right here. That'll be 4 pi over 3. 11 pi over 6 is almost all the way to 2 pi, but not quite. So about right here. And this may not be exactly to scale, but it'll be close. About right here, that's going to be 11 pi over 6. 7 pi over 3, that's 2 1/3 pi. So it's a little bit bigger than 2 pi. So it's probably about right here. And of course all this, is just estimated. So, my graph might not look exactly like the one that I choose, but it'll be pretty close. Alright, so I am supposed to graph the cosine graph with an amplitude of 1. Cosine starts at a high point, then crosses, and has a low point. The low point needs to be -1. I put my point down too far. Then we'll cross, then we will end at a high point. So a real rough sketch would look like this. And the way that we get secant from this, let me do that one more time, is everywhere that we cross, we put a vertical asymptote. At every low point, we draw a U-shaped graph opening downward. And every high point, you draw a U-shaped graph opening upward. Okay, and that would be the graph y equals secant, just the blue graph that I have up here. So let's compare that to what we have for our choices. Alright, so the blue part of the graph looks nothing like A. Not only is this not secant, it's not even, I don't know, it might would be, let's see, no, it's not even cosine. That just looks like a negative sine of x graph. Look at B. B looks kind of close to what we have, but let's check the other choices. C looks kind of close to what we have, and then D is red triangle. My graph wasn't a red triangle, sorry. Alright, so let's look at our graph and see if we can figure out which one is it. Is it B or C? Well, notice that C has a high point or a U-shaped graph opening downward close to 2 pi. Our U-shaped graph opening downward isn't really close to 2 pi. It's further over to the left. So it's got to be C. Ours has got to be C. The reason I changed one of the choices is because it looked too close to the other answer. It looked too close to the actual answer. So I just changed it to red triangle. Alright, now 16 through 20 are the problems that you have to work out.